Welcome back, Warhawks. Today we're going to be learning about chord lengths and tangent line, secant line lengths in circles. So far we've dealt with the angle measurements in circles, but now we're going to be learning about how to find some segment measurements when it applies to circles. We're going to look at chord lengths. So chords are the lines that are inside of the circle. They go from one side to the other. And if we have two chords that intersect, the product of the two parts of a chord is equal to the product of the two parts of the other chord. It sounds complicated, but it's not really. To find a missing length, what it means is here's the two parts of this chord here. Okay, so we have 4 and we have 5. So the product of those, 4 times 5, will equal the product of the other two numbers in the other chord. So we have one of the parts is 2, the other part is x. So 4 times 5 will equal 2 times x. 4 times 5 is 20. 2 times x is 2x. And then if we divide both sides by 2, we would get that x equals 10. So not too difficult there. Let's look at this other question though. So here's this chord. We have the two parts are 9 and 4. So we do 9 times 4, that's product, will equal the product of the two parts of the other chord. So we have x, and again we have x, so think about that. It's not 2x, but it's x times x. 4 times 9 is 36. X times x is x squared. And then to find the answer, we need to square root of 36 to get rid of the squared. So x ends up equaling 6. So with chord lengths, not too bad. Just take the two parts of each chord, multiply them, and set them equal to the other chord. Now we get to tangent and secant lines. So these are lines that can go outside of the circle. Here we actually see two secant lines. We can find their lengths. Now this looks a little complicated, but I'm going to call this line A right here, or secant A, and then over here we'll say this is secant B, and we want it to follow this pattern. So it's the whole length of A times the part that's outside equals the whole length of B times the part that's outside. So let's think about this. So that's not 16, that's just an arrow pointing to B. Make that a little better. So let's see what this. So we have A here. The whole length of A is not 4, it's not 9, it's 13, times the part that's outside, 4, equals the other whole segment. So this is where people get tricked up. We see that the whole segment is not 5, it's not x, it's actually x plus 5 or 5 plus x. Either way you want to think about that. So we'll say x plus 5 is that whole length. So I'm going to have to put parentheses around that to remind myself that when I multiply times the part that's outside, I need to distribute that. So again, it's the whole length times the part that's outside equals the other whole length times the part that's outside. So 13 times 4 is 52. Check. And then when we distribute, 5 times x is actually 5x, and 5 times 5 is 25. So now we have an algebra equation we need to solve. Subtract 25 from both sides of my equation. 52 minus 25 is 27. So 27 equals 5x, because that's eliminated. And then we just divide by 5, and we get our answer. X is 5.4. There you go. So again, with these, it's the whole times the part outside equals the other whole times the part that's outside. Now let's look at a couple more examples with these. Now these are a little tricky, but they do like to ask these questions. So again, these are secant or tangent lines. This happens to be a tangent line, and this is a secant line. So we'll just think about this as being maybe line A, and this as being line B. We'll think about that. So what we want to do here is we take the whole thing, which is going to be x plus 7 times the part that's outside, 7, equals the other whole segment. So think about line B here. The whole segment is 10 times the part that's outside, which is also 10. So it is okay to do that. It's the whole segment times the part that's outside. In this line B, we only have 10, so it's just going to be 10 times 10. Over here, we do 7 times x is 7x. 7 times 7 is 49. And then over here, we have 10 times 10, which is 100. We subtract 49 from both sides to get x by itself. So now we have 7x equals 51. And then I divide 51 by 7, and I get my answer that x is actually 7.3 rounded to the nearest tenth. So again, it's the whole segment times the part that's outside equals the other whole segment times the part that's outside. Let's look at another one of these, a little different. So this time the whole segment, we'll call this the line A, and we'll call this one B. So we have the whole line A, which ends up being 17, times the part that's outside, which is 5, equals the whole line B, which is just x, times the part that's outside, which is also just x. So again, not 2x, but x times x. 17 times 5 is 85. X times x is not 2x, but x squared. And then to get the answer, we need to take the square root of 85, which ends up being 9.2 rounded to the nearest tenth. All right, make sure you write down the notes. Hope you enjoyed it, and we'll see you in class.